There we go. I just needed some technical assistance. That's what it is. Okay, despite what the name tag says, I am not Joe Brockmeyer. He was supposed to give this talk. He could not make it down here from the U.S., so I am taking his place. I am not as pretty. I do not have the goatee that he has, but I will try to do my best. Who has heard of software collections? None of you. Okay, a couple of you. I know there are some folks of you wearing red hats in the background that have actually heard of software collections. Maybe one or two. Software collections for us are a way to provide newer or older libraries than what ship with a system normally. With Enterprise Linux, the lifespan is 10 years. And if you look at EL6, if you look at CentOS 6 or RHEL 6, it shipped out of the box with Python 2.4. How old is Python 2.4? Who's still using Python 2.4? Most people want 2.6, 2.7, 3.3. So software collections is what allows us the ability to do this. So this is pretty much what we're going to go over today and what we're going to discuss in what we're looking at. We're going to talk about the basics for what a software collection is, why it's important to you, how to build your own software collections, and then look at a few real-world examples for how software collections are actually being used right now. So, to start off with, am I speaking too fast for anyone? Do you need me to slow down? Okay, great. Essentially, this is why we have software collections. New software comes out every day. If you were a PHP developer, you're going to want to stay on top of PHP. You're going to want PHP 5.4, PHP 5.5. Generally, what comes with CentOS, with RHEL, with Scientific Linux, you get one version for the life of that distribution, and it does not change. This makes sysadmins very happy because they don't have to keep updating everything. They don't have to worry about changes. It irritates developers because they want the newer versions. They want that newer software. So software collections allows us to bridge that gap. Software collections allows us to provide those newer libraries and those newer features that the developers want, but still with the same tooling and the same framework that keeps sysadmins happy and keeps systems from burning down in the middle of the night. The other benefit that I neglected to mention, I have not had enough coffee this morning, is that you can have multiple versions of a specific library or of a specific application installed simultaneously, and they will not conflict with each other. Now, obviously, if you're running a service like MySQL, MariaDB, or Apache, you're going to need to adjust the ports because you won't be able to have multiple things listening on the same IP on the same port. But beyond that, you can have multiple instances running at the same time, and they don't conflict. It is entirely per instance. When I say they're per... Whoa, too close. When I say they're per instance, the software collections are essentially namespaced libraries. So you will have, when you go to install a package, you'll have Ruby 1.9.3, Ruby 2.0. You will have these different versions, and they install into a specific directory /ops/rh/ Ruby 1.9.3 /Ruby 1.9.4, whatever the case may be for that specific package. So this is how we get around having those packages installed at the same time without them conflicting. Now, from a programming standpoint, this is similar to Python's virtual environment. It's similar to an RVM, but you don't have the headache of being able to, or rather not being able to track those files or track those file locations. If you install, or if you build up an RVM or a Python virtual environment, the system itself has no idea that those files exist or where they are or how they're operating. With software collections, that's not the case. The same tools for RPM, for Yum, they're aware of those files. You can install them. You can create dependencies back and forth. So it gives you a lot of flexibility for how you want to do things. We touched on this a little bit with the system administration tools. So how many of you actually run RHEL, CentOS, Fedora, something along those lines? Hands? 1, 2, okay. So yeah, it's just the Red Hat folks participating in this. Fantastic. The rest of you are here too. You're free to participate. If you don't run CentOS, I'm happy to provide download images for you after the fact. We can see about, getting you some installs on the side. We can fix what you've got. The basic tool set installs just the same as a normal package. So you run yum install whatever the name of your software collection is. If you're installing a software package like Foreman is built on software collections. You just install their package, it pulls everything in for you, and then you have essentially everything that you need. This keeps the system administrators happy because they can use their same deployment techniques. They can test packages and go from development to testing to production. They can run their own repositories of these software collections and have everything available to the developers. The developers stay happy because they get the newer libraries. They get the ability to link against a custom package without endangering the system and without having a fight back and forth with a system administrator. To get started with software collections, it's really easy. For CentOS, and I have a little bit of a bias here. I tailored this talk kind of toward a CentOS crowd. I may have been a part of the CentOS community for the last decade or so you'll have to forgive me a little bit for being a little biased towards CentOS. But these are the basic commands that you do, and this will allow you to use Python 3.3 on a CentOS 6 box. By default, you ship with Python 2.4, so this is how the two will interact. So once you run these commands, and it's essentially just these 3 commands: yum install CentOS release SCL, yum install Python 3.3. Closer? Okay, I'm being told that, whoa. So that's how that sounds up here. Okay. All right. Once you run the SCL enable Python 3.3, then you get the ability to pass additional commands to that. So you can pass your application command. In this instance, I'm cheating and I'm just using bash. It's the easiest to test with and show how the operation goes. But you can run this with Django, you can run this with other Python applications, and this will allow them to use the newer Python 3.3. And from a shell perspective, what this looks like is on the screen right here. SCL enable Python 3.3, and then if you run that through which, just to find out where the application is, you'll see that it is opt Red Hat Python 3.3, and then you'll see a root user. No worries. Each software collection does a bit of a root path hijack. And hijack is kind of a bad word for what it does, but there are some path options that get overridden when you run the enable. So it adds to the beginning of your path so that Python command or that Ruby command becomes the first thing that you're running. And you can see that in how the path is created here. And then it also shows, Python version shows me that I'm now running Python 3.3. So again, here's what I'm saying for how that works. You'll see the directory structure that gets created. You've got bin, you've got boot, you've got dev. It creates a basic system structure inside that directory and then re-aliases a few of the links. So you'll see that lib goes into this directory's user lib, the same with 64, the same with sbin, bin. So this all gets created inside the directory. Everything you need for your application gets put inside that directory. So as you install Python modules or as you install Ruby modules or gems, however you put that in, it ends up in this directory. So you get the ability to extend the system as much and as freely as you want without impacting the basic standard layout for the system. And this is the case for each one. I mentioned earlier that you have the ability to kind of tree these out and establish dependencies. So if you want to do that, and in this case we're enabling Python 3.3 and Ruby 1.9.3. I have no idea why you would want to do this in a production environment, but for the sake of testing it works really well. And this just shows again that we're running a bash shell with this. We're enabling Python, we're enabling Ruby, and you can see that the versions are updated so that each one is what's available. Are there any questions so far? The folks who are running translation in the back are happy to go back and forth, so if you have a question, feel free to ask. No? Okay, great. So to get started with building SCLs, it's pretty much 2 more packages that you have to add in. Yum install SCL utils. That will come in by default once you start using software collections. The very first software collection package you pull in will load that package up automatically. It's the build package that you need to primarily be concerned about if you want to start packaging these yourselves. For the most part, it is a few simple twists on an existing spec file to build the package. It's a few macros here and there, and there are several tools that make this really easy. The biggest one is from Fedora's extra packages repository from the EPEL repository. It's called spec to SCL, and it makes it really easy. You basically point that application at your existing spec file, and it creates everything for you, and then you just run RPM build or mock as you normally would, and you're off and running. It's very good at converting packages for you. So keeping this going, we've got the general instructions for packaging. It's basic documentation. I didn't know how technical we were going to be able to get on this. I picked this talk up from Joe a week ago once we found out that he wasn't actually going to be able to make it. So I wasn't sure how in-depth he was looking at getting. And then as far as the real-world tools that are actively using software collections, we've got OpenShift, which pretty much runs on software collections. Every single facet of OpenShift, from their containers, from their gears, it's all built off software collections. That's how they enable you to have the multiple versions of PHP for your application, or the multiple versions of Python for your application. This is how they do it. The Foreman project, what's going to be, it's Satellite 6, I believe, that Foreman is the upstream for. It is entirely software collections based. The entire goal of this is to make life as easy as possible for the system administrators and for the developers, so that you're able to get the toolkits that they need to keep doing what they want to do. The last thing that we had on the list was essentially Django, and there is a how-to, and it's a basic walkthrough that Langdon White wrote that walks you through how to install Django with the newer Python on CentOS 6, on RHEL 6, so that you can use and do development for it using software collections. It doesn't take that long at all to walk through. I think he has like 8 steps, and you've essentially got Django up and running on your web server with newer software collections. I finished this talk entirely too quickly. Please ask lots of questions so that we can fill up the rest of the time. No. Okay, I got a smile from one person about that. Yes.
When you say that all this software is running under SCL, what does this exactly mean? Do they want to run with different versions, or?
Yes, it allows them to run on a basic RHEL 6 instance or a basic CentOS 6 instance. The default Python or the default PHP is often significantly older than what most distributions want. From a Fedora standpoint, Fedora can in some cases outpace what developers want. When Fedora is changing every 6 months, a long-term development project might lag back by a year. They may have tooled for Rails 3, where Fedora's charging forward with Rails 4. So while they're doing that new development, they might use a software collection on Fedora to maintain their Rails 3 application until they can get that development to catch up with Rails 4. For CentOS, for RHEL, it's usually the opposite problem. 2 to 3 years into that 10-year life cycle, PHP developers and Ruby developers are howling and screaming that they want newer versions, and Python 2.4, 3, or whatever it is that RHEL 6 and CentOS 6 ship with starts looking a little old. So if you're looking at doing newer Python toolkits or doing it for scientific purposes using NumPy or something along those lines, you want Python 2.7, you want Python 3.3. This allows the developers to do that without breaking any of the system tools that use Python, like Yum. Breaking Yum on an enterprise Linux system would be bad. That would do angry things. Yes? No, it is not the same as the... actually, we'll do some of this live. Sure, why not? The alternative script sets the default system-wide. So you will have a user, when you set that, let me see if I can drag this. Oops, don't want it that big. Okay. We'll do that. All right. Let me see if I can I talk it? Okay. Yeah, so I just need to talk closer on this one. All right, there we go. So for alternatives, that sets it system-wide. And if I'm doing this for just one screen, if I look for Python now, it's user bin Python. And the Python version is 2.7.5. I'm running the RHEL 7 RC right now, so we've been testing it and beating on it for a while. Ignore the Python version here not being the EL6 Python version. So now if we do... I can't type. Okay, so now we've just started another bash session. I'm treed down a little bit, and we have a brand new thing here. Now if I open up another terminal right from that same session, this one's still the original version, so it is per instance. So every time I run that application, I can choose to reference the newer version of Python or not. So every single time I have that option. Most of the software collections for scripting for services have this built in. The one thing that you can do if you wanted to cheat, and this is terribly unsupported and they yell at me every time I show folks this, is it too dark? Okay. Okay. How's that? Can people? All right. Great. All right. Fancy. Okay. So for the original version here, yeah. All right. There we go. Everything is per instance. In this directory, there's an enable file, and that enable file is where a lot of the magic happens. So if we look at that enable file, you can see exactly what they're doing. See that they are essentially exporting a path that puts the new Python right up front. They're hijacking the LD library path to put the new version up front. They're extending the man path, and then they're adding a few other variables that Python needs. So if you wanted to, And again, like I said, this is highly unsupported. The global services support folks will probably scream and yell and take me off to the side and flog me after this. You can actually source this enable file. It's just a bash shell script. You can source it on startup. Throw it in your bash RC, throw it in your bash profile, and you can have, per user, they can have this version by default right out of the box. There are a couple of packages where that doesn't work, but for the most part, for all the user tools, Python, Ruby, that a developer might care about, so far I haven't run into any problems with it. So you can just enable this or toss it into your bash RC. The one thing that they haven't put into software collections that I would really like to see them do is to tie it in with the alternatives framework. If you had the ability to run it per instance or to set it as the system default, for the most part, that would be fantastic. A couple applications like Yum might need to be tweaked specifically so that you're using the proper Python version, but overall, this makes things really easy to do. So now that you guys can read the terminal and see what I was trying to show, are there any other questions? No? Okay. There were bribes and stickers and little handout things earlier, so if you didn't... yeah. It has to be green. I learned that too.
Okay. So I would like to know if you install HTTPD, for example, as a software collection, where does it place its log files? Does it place it in /file log, or does it place it somewhere else?
The lock files, it's up to the packager. The convention is to place them in the normal system lock file location.
Okay.
So it can change. There isn't any specific rule for it, but convention dictates they go in the normal locations. In the init scripts, whether it's systemd or the sys5-ish upstart packages that RHEL 6 uses, the init scripts go in the normal location, etc initd or user lib systemd or wherever systemd puts it. I haven't learned systemd yet. I know you don't roll your eyes at me for not learning systemd yet. Those all go in the normal location, and most everything is linked back. So you saw in the directory tree listing that a lot of it was done as an alias or as a symlink. So it will be in the Red Hat or in the software collection directory as a symlink back to the real location.
Okay, thanks.
Mm-hmm. Any other questions? Okay, we burned through. Oh, no? Okay. We burned through fast. Have a good lunch, everybody. She doesn't even have to hold the sign up to tell me 10 more minutes.